right, how you guys doing? Do you miss me? Hey, I hope you feel like you did good on your quiz. And now we're moving into 11.4. So we have spent quite a bit of time on two-dimensional figures. We did a lot with quadrilaterals, triangles, most recently circles. Well, now we're finally getting into three-dimensional figures. And of course, that means that there is depth. That's the third dimension. And so we'll get into things such as volume, and surface area of three-dimensional figures. And so with three-dimensional figures, you have a lot of specific parts that make up those figures. And the things that we'll be focusing on are things such as vertices, edges, and faces of three-dimensional figures. And so we first start with what are known as solids. Solid is basically anything that is three-dimensional. And so we call any of those solids because there is space on the inside of them. Now they can be bounded by flat or curved surfaces. And so if it's a solid figure that is made up of polygons, that is known as a polyhedron. And all the individual polygons that make up the polyhedron are called faces. So if you look down on this picture right here, every face of this three-dimensional figure by itself is a polygon. Therefore, the whole thing is a polyhedron. Now, what allows one polygon, so let's say this front trapezoid, to be joined to this rectangle over here, well, where they're connected, that's called the edge. So the edge belongs to both polygons. And then when you have three different edges meet, three or more, I should say, they meet at a vertex, which is a word that you've seen before. And so if it's made by polygons, it's a polyhedron. If it's not made by polygons, it's still a solid, but it just wouldn't have that polyhedron title. So here are some examples of things that are polyhedrons versus things that are not. So these two over here, you have a prism and a pyramid. They are made entirely up by polygons. You have all the edges of the prisms meeting, all made by rectangles. Here you have edges that meet at what's called the apex of a pyramid. But over here, because you have part of it that is curved, these would not be considered polyhedrons, but they'd still be considered solids. And so when it comes to prisms, you name the prisms by the bases. So we have a pentagon on top, we have a pentagon on the bottom, and rectangles joining all the lateral faces, and that would be a pentagonal prism. If you had a pyramid, the pyramid is also named by its base. It only has one base, and so this would be a triangular pyramid. All right, so a little bit more about prisms. They are a polyhedron, and their bases must be congruent, and their bases also must be parallel. So in this example, you have a pentagon on the bottom, a pentagon on the top. They are congruent pentagons, and they are parallel to each other. And then all the lateral faces, lateral means side to side, all the lateral faces are rectangles. And so because they are rectangles and the bases are made by polygons, congruent polygons, we would name this by whatever shape the base is. And so this would be called a pentagonal prism. And all the lateral faces of any prism are always rectangles. Quick sidebar, all the lateral faces of all pyramids are going to always be triangles. All right, so determining whether or not something is a polyhedron, basically ask yourself, is every possible face a polygon or not? Well, in A, yes, that is a polyhedron, and you'd call this a rectangular prism. For B, we have a base that's a polygon, and all the lateral faces are triangles, which are also polygons, so this would be a polyhedron, and we'd call that a hexagonal pyramid. Option C, well, obviously the base right here, not a polygon. It's a circle. And so because of that curved surface, we know that it's not a polyhedron, but it still has a name. We'd call that a cone. All right, a couple more. Number one, what do you think? Yes, it is a polyhedron because it would be a square pyramid. Number two, well, you have a polygon here, which appears to be a rectangle, but then because of the curved surface, that would not be a polyhedron. And then this one over here, it is a polyhedron. What do you think we'd call that? Well, the bases are actually the triangles right here, and then the lateral face is a rectangle, so you'd actually call that a triangular prism. All right, I need to pause it for just a second. Hey, look at that, I'm back. All right, so now when you have a polyhedron, you can develop what are called cross sections. And it's basically if you were to slice through a solid figure. Or another way to think of it is if you took a piece of paper and could just slide it through the middle or a section of a polyhedron. So in this one, the tannish figure, if you will, that is what's slicing through what appears to be a cube, but the purple section is actually the cross section. So it's where if we treated this tan section as a piece of paper, if we're sliding this piece of paper through the cube, where the piece of paper and the cube actually intersect is this purple section, and whatever shape that is, the purple area, that's what we call the cross section. So if you're being asked to describe the cross section, we'd say that this cross section is a square. This cross section would be a rectangle, whereas this cross section through the corner of this cube, we'd actually call a triangle. So whatever shape is made by the cross section, or by the thing that's doing the slicing, we call that the cross section, and we just name the shape that it makes. So here are some more examples of this. So here we have a hexagonal prism, but look at the purple area. That's just a hexagon. So the cross section would be called a hexagon. Here we have what appears to be a triangular pyramid, and the cross section is the purple, and so that would just be a triangle. And this is an interesting one. It's a curved figure because it's a cylinder, but if you actually look at the purple section, that's just a rectangle. So the cross section is always going to be some type of polygon or two-dimensional figure. Here's some more. You have a cone. Well, the cross section of a cone, if you go parallel to the base, is always going to be a circle. If you have a sphere, anywhere that you slice a sphere, the cross section is automatically going to be a circle. And then this appeared to be a cube with kind of an interesting cross section. What do you think that one looks like? That is actually a trapezoid. And if you follow the purple, we have there, 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 and there, and that makes a trapezoid. Remember, the cross section can only be a two-dimensional figure. All right, so now this might be something that you haven't seen before. This is if you take a two-dimensional figure, and what would happen if you actually rotated it around an axis of revolution. And so it's as if you're spinning it to make a two-dimensional figure into a three-dimensional figure. What would it create? So for example, if we take a rectangle, so here, look at the left picture right here. This is just a two-dimensional rectangle. But if the whole thing spun around this axis, what shape would it make? So you can see as it starts spinning, so here's the original rectangle right here, but we're spinning it around all the way. And if you spin that single rectangle all the way around, it actually produces a cylinder, which is kind of cool. And so the axis of revolution doesn't change, it doesn't move, it doesn't go to a different spot itself. What's moving is the polygon, and it's spinning around the axis of revolution to create a three-dimensional solid. So a rectangle would actually produce a cylinder. All right, so now here's another rectangle. Now your axis of revolution is horizontal, so the rectangle, imagine it spinning towards you and all the way back to where it started, and you would get, again, a cylinder. If you had a triangle and you spin it around the axis of revolution, well, the vertex up here doesn't move, but this one spins all the way around, and what's it going to create? It's going to create a cone. And so the solid figure would be a cone, not a polyhedron, but it is a solid figure. So here are three examples to try on your own. So think about these. If you spun them around the axis of revolution, what figure would it make? Well, the triangle results in a cone. The rectangle, we kind of already saw one of these before, is going to become a cylinder. And then what's this one? It's a semicircle, but if you rotate it all the way around, what's it going to produce? It's actually going to produce a sphere. So anytime you're sketching a solid by rotating it around an axis of revolution, it's going to have a curved part to it. So your options are pretty limited. You have a possible cone, possible cylinder, maybe a possible sphere, but all of these have some type of rounded nature to them. All right, so that's it. You should have gotten the packet from the sub. Some of the notes that I went through, you can just write those in on your packet. And then there's kind of two assignments. The first one's in the guided notes, and then the second page that's stapled to it, there are 20 questions for you to practice. You will also get time on Wednesday during class to work on this, but the goal is to have the packet finished by the end of class on Wednesday. All right? Okay, I will see you guys later, and I'll have your quizzes back for you on Wednesday.